Welcome to Week 10 of Technology and Education. This week our focus is on algorithms and automation. Let's take a moment to look at the learning targets. As a result of your work this week, you should be able to relate the concept of algorithms to daily activities. You should understand the difference between an algorithm and a program. You should be able to identify the attributes of a good algorithm. In other words, an algorithm that is correct and efficient in sample code. And finally, you should be able to identify resources for teaching and learning about algorithms that you can use with your students. You'll see that I've added an additional challenge. Identify the code pattern in the Make a Masterpiece exercise. Use your understanding of the pattern to include additional colors in the palette. This will make a little more sense to you when you're actually in the activity. I hope you'll be up for the challenge. There are extra bonus points if you are. Now let's look at how we're going to get there. Krauss and Protman define algorithm as a list of steps that can be followed to carry out a task. McGrath defines algorithm as a well-defined sequence of instructions to perform a specific task. There's an algorithm on this page. Do you see it? How does this algorithm connect with the two definitions that we just examined? Algorithms are widely used in computer science and programming, but algorithms are important problem-solving skills for students in everyday life as well. Algorithmic thinking is the use of algorithms or step-by-step sets of instructions to complete a task. As humans, we learn by experience. We learn by seeing others solve problems and by solving problems ourselves. Being exposed to different problem-solving techniques and seeing how different algorithms are designed helps us to take on the next challenging problem that we're given. By considering a number of different algorithms, we can begin to develop pattern recognition so that the next time a similar problem arises, we're better able to solve it. Teaching our students how to use algorithmic thinking prepares them to approach new problems with confidence. Before you begin working on the online activities, read Chapter 10, Automation, in Computational Thinking and Coding for Every Student. When you're ready to move on to the online activities, begin with this video by Khan Academy. It goes over algorithms used in computer science and everyday life, and I think by the end of it, you'll really understand how algorithms make code far more efficient. After the video, you should move on to the section called Teaching Algorithms. There you're going to find a number of lessons and practice activities that help you to better understand algorithmic thinking so that you can help your students with an understanding of it. When you get to number 3, you'll select from an elementary, middle, or secondary level activity to complete. As you work on your activity, please think about how you might integrate it into a lesson that you're already teaching. I'll end by summarizing your assignments this week. Make sure you read Chapter 10, Automation, and then take the Chapter 10 quiz. In your Python practice book, complete the activities on page 54 to 59. This will include the exercise Don't Press the Button, as well as Make a Masterpiece. You'll be turning in Make a Masterpiece by submitting 2 files to me. First, your Python module file, the program file, and then second, a screen capture of the masterpiece that you design. In other words, you'll be creating a painting using the paint program that you wrote in Python. I think you're really going to enjoy this, and I'm looking forward to seeing what you come up with in your paintings.